to maybe mute themselves. I'll ask everyone to mute themselves now so that we don't get any background information or background noises. And then at the end, you can unmute yourself or put your questions in the chat room or raise your hand. So we'll do that at the end of the presentation. So with that, it's my pleasure tonight to introduce tonight's speaker. Dillon Fogarty is a PhD candidate and program coordinator for working lands conservation at the University of Nebraska. He previously worked for South Dakota Game, Fish and Parks, and the Minnesota Department of Natural Resources as a wildlife technician. His topic tonight is new strategies for reducing woody encroachment and conserving North America's vanishing prairies. Dillon, I'll let you tell a little bit more maybe about yourself and then present your presentation tonight. We appreciate you having you.
Thanks, Mark. So I know people have presented on woody encroachment and the threat of it here before. Thanks for having me come this time. And I'm excited I get to talk about solutions tonight. So in 2021, myself and let me get this set up. All right. And some colleagues, Drac Twidwell and John Weir at the University of Nebraska, Drac at University of Nebraska and John Weir from Oklahoma State developed a guide for reducing woody encroachment. And so what it does is it provides the first unified framework that we have in the Great Plains for managing woody encroachment. So I'm excited to share that. Can everybody see my screen?
Yes, I can.
Awesome. All right. So what I'm going to cover tonight is I need to start with a little bit about how grasslands work and why woody encroachment is such a problem. We're going to talk about what we can do about it. Before we dive into that, I think it's important to touch on our traditional approach to dealing with the problem and some of the lessons learned from those past approaches before we jump into new frameworks. Then I'll have some examples from the Great Plains of where this new guidance is being implemented, as well as opportunities for people, for land managers in Nebraska. And so I guess before I'll start is I'll just touch real briefly on some new initiatives for grasslands in the Great Plains, because I don't cover that in my presentation, but there's been a lot of action, a lot of movement on the grassland conservation front over the past several years. Drac Twidwell's lab has really led that out of Nebraska. But there's been now connections with Working Lands for Wildlife and multi-state NRCS initiatives. So we've actually been able to take some of the principles and frameworks from this new guidance and incorporate that into NRCS cost share programs for managing grasslands. Because the Great Plains is almost entirely privately owned, that's really important that we have agencies like the NRCS who distribute lots of money from the Farm Bill for land management, adopting these new strategies. So we actually have a new initiative, the Great Plains Grassland Initiative, that's prioritizing grasslands and maintaining them as intact and reducing woody encroachment in there. So lots of exciting things going on. Lots of examples of where some of these new guidelines are being implemented that I'll get to at the end of my presentation. All right, so I wanted to start here. What's motivated all of this work is how can we conserve grasslands in an era of woody invasion? So I'm going to talk mostly about eastern redcedar tonight, because that's really what's driving woody encroachment in the Great Plains, and for a large portion of North America, actually. But if we look at this map here, we see that woody encroachment it's a global problem. In our grasslands across the world, we have native tree invasion. And so what's happening is we have our grasslands that have been maintained by fire. And when we remove fire, the expectation is we have a transition to an alternative state. That's a woody state. So they're fundamentally different. And that's why I've represented them here in this ball and cup diagram. It's actually a transition from one ecosystem type to another, is what's really happening. Woody encroachment's the process, is that transition process. So a little bit on how grasslands work. They are the fire dependent biome. This map here shows the fire return interval for the Great Plains. The darkest areas down in Texas is a fire return interval of less than 2 years. So these grasslands burned a lot, and that helped maintain these large, expansive, intact grasslands with very little exposure to trees and shrubs. That fire, they've done studies and looked at the history and the role of lightning versus people. And what they've concluded is that indigenous tribes in the not just the Great Plains, but really globally, were fire users. They were able to harness the power of fire and use it to create an environment in which they could thrive. I put a quote in here from the Lewis and Clark journals. This is north of Omaha. I thought it was fun to include, but talks about a fertile plain as far as the eye can reach, not even a single shrub or tree, except that are sheltered from the ravages of fire. So even in a landscape that's has a lot of trees on it today, when we go back to these historical accounts, that we see comments on fire and smoke and just the ocean of grass and vastness of the Great Plains. That vastness is driven by fire vegetation feedback. So this is research out of Kansas that's really studied these woody transitions. This is a tall grass prairie. So they found a 1 to 3 year fire return interval maintains grasslands. As fire becomes less common on the landscape, you get a transition to shrubland and woodland ecosystems. Now these years are going to be different for different places in the plains, but the idea that fire vegetation feedbacks maintain, so when we have high fire occurrence, high intensity, we get grass. When we have low fire occurrence, low fire intensity, we're more likely to get woodlands. In fact, up until recently, the best way we could kind of look at biome level changes was through vegetation simulation models. So in this really famous paper from 2005, William Bond actually simulated the distribution of grasslands in a world with and without fire. What he found was that 50% of the grasslands would be lost if in a world without fire. Now, two things there. We can't actually remove fire because the Western US is a great example of what happens when we try. We get wildfires. Nebraska's seen that this spring with a lot of wildfires. These systems are designed to burn. Second, when we account for increasing atmospheric CO2 concentrations and adaptations in woody species, the current expectation is that we'd actually lose a heck of a lot more than just 50% of our grasslands. I had the opportunity to talk to William Bond about it, and I said, what do you think? Do you think that prediction from 2005 would underestimate things today based on what we learned? And he said, absolutely. I think we'd see much greater loss of our grasslands given a lot of evidence that's come out since then. But still, 50% loss of grasslands is an incredible reorganization of our biomes globally. With some recent advances in remote sensing, we now have the potential or the ability to track these woody transitions over space and time. So what we have here is an early warning signal that tracks woody transitions throughout the Great Plains. What this signal is tracking is a conflict between grasses and trees. So it's these two distinct ecosystems. When one increases, the other decreases. So this map shows where we're having conflict between trees and grasses. Everywhere in red shows where the woody plants are winning at the expense of grasslands. So we have Halsey National Forest in the middle of Nebraska. We have the Black Hills. We have some native forests in eastern Oklahoma and Texas. This is in 2000. By 2018, we see the woody biome expanding. So let's go back to 2000. We see the red. Over just 18 years, we're seeing that woody biome rapidly expand across the Great Plains. This has been referred to as, before we had this kind of data, it's been referred to as the Green Glacier by Dave Engel, who studied woody encroachment for decades out of Oklahoma State. And he talked about it as the Green Glacier because it's the most significant change, vegetational change in the Great Plains since the last glaciation. And so it's a change that's best measured on a geological scale. And so, I mean, to think about that is really puts it in perspective. You know, we talk about climate change and the impact that that's going to have globally on our systems. Well, in grasslands, fire functions like climate. You know, the distribution of grasslands is dependent on climate and fire. And so when we change climate, we expect large-scale changes in our ecosystems. That's what we're seeing. When we change fire, we expect the same thing. And that's what this data shows is happening. But it's pretty remarkable that we can see this kind of change over 18 years at such a large scale. Nationally, when we look at our rangelands, so we can now track changes in all vegetation functional groups: annual grasses, perennial grasses, shrubs, trees, bare ground. The biggest change, increasing trends are shown in blue, decreasing trends are shown in red. When we look at compare the changes across different plant functional groups, we see that, increasing tree cover is the biggest changes rangelands in the Western US have experienced from 1999 to 2018. So this is a national rangelands problem. In Nebraska, this is a study we published in 2020. Outlined here are our priority conservation landscapes called biologically unique landscapes in Nebraska. We wanted to know how sustainable grassland conservation was in these landscapes. So are we losing them with our current strategies, or are we able to maintain what grasslands we have? Everywhere in red on this map shows where we've lost grasslands, where woody cover has increased from 2000 to 2017. In the tallgrass prairie, the mixed grass prairie, the sandhills, we saw ecoregions as a whole, we saw unsustainable trends of woody encroachment. The shortgrass prairie was the only ecoregion where tree cover was stable over time. When we looked at all the BULs, the vast majority of BULs showed, or priority areas, that is, showed these unsustainable trends of increasing woody cover and grassland loss. The Les Canyons down here, south of North Platte, and the middle Niobrara were the only priority areas that had a trend of encroachment that was stabilized over time. In the middle Niobrara, we attributed that to wildfire. And in the less canyons, we have some of the most progressive prescribed burn association, the most progressive prescribed burn associations in the state. They've actually been able to halt woody encroachment through their management. Very impressive given the sheer amount of woody encroachments that has happened in that landscape over the past 20 years. So what are the consequences of woody encroachment, of losing our grasslands to this woody dominated state? We have a collapse in grassland biodiversity. That affects our pollinators, our grassland birds, endangered species like the American burying beetle. We have impacts to rancher livelihoods. Forage production and livestock production decrease by up to 75% when we have woody encroachment. We have increased risk of wildfire disasters. If you guys can see my cursor, this is a grassland fire, small flame lengths. This is what happens when juniper woodlands or eastern red cedar woodlands combust. We have much greater flame lengths, much greater risk for large wildfires. We have impacts to human health. Juniper species, including eastern red cedar, contribute to hay fever and seasonal allergies. In Tulsa, Oklahoma, they've been able to track an increasing amount of pollen load due to woody encroachment in the region. We also, with new research coming out of Oklahoma, they've linked woody encroachment of grasslands to increased risk of tick-borne disease and mosquito-borne disease, particularly West Nile virus. We have reduced water supply across. Impacts to water vary across the Great Plains, but overall we see reduced water supply. And what it essentially comes down to is trees, especially eastern red cedar, have potential to use a lot more water than our grasses. In Nebraska, we lose funding for public education. The Board of Education Lands and Fund is the largest landowner in the state. They use revenue from grazing lands for funding for public education. As they lose productivity to woody encroachment and have to spend more of their revenue managing woody encroachment, that takes money away from public education. We also have cedar apple rust, where we have risk to apple production due to a fungus that requires eastern red cedar in its life cycle. There's actually some really interesting history on eastern red cedar and cedar apple rust in Nebraska and how we've regulated that problem in the past. Anyway, so we have all these fundamental large-scale impacts that can happen in grasslands as we transition from grasslands to woodlands. All right. That's all the stuff that we all should know. But really what we want to get to is what can we do about it? Now that we know what's going on and a little bit about why it's happening. So really quick, before we dive into the new guidance, I want to take a quick look to our past and look at some of the lessons learned from past management. So let's think about these woody transitions again from 2000 to 2018. Over the course of the last Farm Bill, we spent $177 million on brush management. That's mechanical tree removal using heavy equipment. Most of it's implemented where woody infestations are the worst. 177 million spent, and the problem got worse. The point of that is we've thought about this a lot. We've done a lot of research on it. The traditional focus has been reactive, and that has severely limited what we can do about this problem. So this graph here shows the cost of impact, and the density of eastern red cedar. It's generalized here for invasive species. But this is what we get is this curve like this, where as cover increases of the invasive species, the management treatments get more expensive. It's not all that surprising. But it shows that if we wait, we're going to spend more on management, and we're going to have impacts, and we're going to be able to, given the same amount of money, we're going to be able to impact less of an area. So a huge focus has been on shifting from these expensive, intensive treatments to more proactive treatments that can cover a lot more ground and can keep grasslands intact. One of the things of the brush management paradigm has been this almost sole focus on restoration, which is important. But what happens is we're missing the front lines of encroachment. So we're focusing on restoration where it's real bad, but at the same time, we're losing grasslands that we could have been defending with a lot for a lot cheaper of a price. New guidance builds on these lessons learned from the past. So we developed this guide in 2021 with collaborators from extension faculty from across the Great Plains. The guide is built around the ecology of woody encroachment. Woody encroachment is a 4-stage process that starts with seed dispersal. Seeds turn to seedlings, seedlings turn to mature seed-producing trees. Over time, we have spread and encroachment. We transition to a woodland state. These different stages provide targets for management. Traditionally, management has targeted this stage, mature trees, and this stage, eastern red cedar woodlands. What new guidance does is we talk about how multiple stages can be targeted to improve the effectiveness of management. Another central point of new management is recognizing that woody encroachment is spatially contagious. So these different stages of encroachment occur in landscape spatially. We have the intact grassland stage. That's a grassland with no exposure to seed sources. Sorry about that. It has no incoming seeds, no seedlings, it's treeless. Then we have the dispersal and recruitment zone where we have incoming seeds and we have seedlings, but we don't have seed-bearing trees. Then we have the encroachment zone where we have active expansion of seed sources. So this is where we have encroachment by mature seed-producing trees. They can reach, eastern red cedar can reach seed production within 5 to 6 years when trees are about 5 feet tall. Then we have the woodland transition phase. So these stages occur spatially, which we can target with our management. They're really important to understand those stages and where they exist on the landscape when we're managing, because if we can map the stages of encroachment, we can detect the front lines of encroachment and we can defend our intact grasslands and then build those intact areas over time. We can push back against the encroachment process. The next point, and this has been really big and really been able to change the way we manage encroachment, is recognizing that seed dispersal distances drive the advancement of woody encroachment. So this is based on research out of the sandhills that we did a couple of years ago. We looked at recruitment distances. So when we have a seed source, how far do we see recruitment from that seed source? We did this study at Halsey National Forest, where we can study a undisturbed encroachment process moving out into a grassland. And what we found was that 95% of recruitment occurs within 2 football fields of a seed source. So we can manage football fields. We can manage eastern red cedar dispersal. The other 5%, that's important, but it can be managed a lot easier with monitoring and early detection, rapid response approaches in those areas that are further than two football fields from a seed source. A little bit more about dispersal and the longevity of seeds. We have recruitment, 95% of it occurs within that 200 yards. Those seedlings will take 5 to 6 years at the earliest before they start producing seeds. Once those seeds are dispersed, they're viable in the seed bank for 1 to 2 years. After that 1 to 2 year mark, there's a very small percentage of those seeds that are going to remain viable for longer periods of time. And there's been no research on what happens to that small percentage after the 2 year mark. All we know is that about 96% of seeds have either sprouted or are no longer viable after the 2 year mark. And so when we put this all together, we get a vulnerability framework for reducing the risk of woody encroachment in grasslands. And this is built around how we understand grasslands. So grassland sensitivity to encroachment is largely dependent on fire. Historically, grasslands burned a lot. With that common fire occurrence, the woody plants simply couldn't exist in the majority of grasslands. We also have factors like soil and climate with that influence how sensitive a grassland is. So wetter areas that can support more rapid rates of encroachment are going to be more sensitive to encroachment. But the point here is that fire is something we can directly control in our grasslands. We can, through use of fire, we can make them less sensitive to woody encroachment. And we have exposure to the source of the problem. This is seed dispersal. We have a good understanding of the spatial dimensions of exposure. Where we have a seed source, we have that 2 football field buffer area where we're going to have a lot of seed dispersal and recruitment. Historically, eastern red cedar and other trees were rare species in the Great Plains. So what's changed is that they're no longer a rare species. We've fundamentally changed exposure in the Great Plains through introducing seed sources as shelter belts, and then what's happened as encroachment to expand those seed sources. But it's something that we can manage. So past guidance has kind of missed that step that we can actually manage exposure. We can reduce a grassland's exposure to seed source. Has been a big gap from past guidance. And then within this framework, we have adaptive capacity, which ultimately sensitivity, exposure, and adaptive capacity ultimately determine how vulnerable a grassland is to encroachment. Adaptive capacity is the potential to adapt to a threat or problem. And so we see, things like cost share programs that give people, that support people's ability to manage encroachment, that can increase adaptive capacity. Working with your neighbors, that's an example of building adaptive capacity to tackle a problem. Now what I want to do is I want to go through all of the stages of encroachment and just talk about a few best practices for each stage of the encroachment process. So let's start with intact grasslands. Again, this is the easy way. When we're reducing vulnerability in grasslands, this is the goal. If we can get to an intact grassland state, they require minimal management. They're more resilient and more likely to withstand large scale changes large scale threats over time as we can build large intact grasslands. In the dispersal and recruitment zone, right, we have seedlings and incoming seed. This is where we mark the front lines of the encroachment process. In this area, the most important thing is to prevent new seed-bearing trees. So if we can prevent those seedlings from becoming seed sources, we can halt the encroachment process. In the encroachment zone, again, this is where we have mature seed producing trees. The fundamental change here is we go from talking about how vulnerable a grassland is. At this stage, the grassland becomes a source of vulnerability. Now we have seed sources that are making adjacent grasslands more vulnerable to woody encroachment. The best management practice here is to eliminate it when possible. If we can reduce grassland exposure to seed sources, that's the best management practice here. What's happened in the past is treatments have come through and they've removed maybe 90% of the trees, but they left 10% because they were really difficult to get to. Maybe they would have needed different equipment because they were on steep slopes. What we're now seeing with this new guidance is people putting in that extra little bit of work to clear cut and remove all of the seed sources so they can have that big reduction in the site's overall risk to re-encroachment. We've got the woodland transition stage next. Restoration at this stage is costly. It requires follow-up management. And that's because we have residual seeds and seedlings after treating this area that really drive a rapid re-encroachment or re-invasion process. The best guidance for working in this stage is that we should be strategic, and we should be targeting areas where we can benefit our more intact grassland areas. So where we have small woodland patches embedded within a broader grassland, intact grassland, we're going to get the most bang for our buck when we target those areas that are risking our more intact grasslands. When we put this all together, we get a spatial game plan for managing encroachment. So what's traditionally happened is we've started in the woodland transition and we've chased the problem into intact grasslands. What this approach does is it flips the script. So now we're anchoring efforts in intact grasslands and working towards the problem. One of the things that this does, that's really important, is we're making grassland conservation spatially contagious. So what we've traditionally done is it's been referred to as the shotgun approach, where we're going out and we're managing here and we do a restoration and we do another restoration over here and another one somewhere else in the landscape. What this process does is it allows us where one project can build on the next. And we can anchor to our intact grasslands and then build out from there. One of the reasons encroachment has been so successful is it's spatially contagious, right? We have one seed source, it creates more seed sources, and it spreads over time. If we can create that same process with grassland conservation, it gives us a chance to scale up management and conserve some of our last grasslands. What's emerged is this new mantra called defend the core, grow the core. This illustration, I think, does a really good job of explaining it. In blue here, we have intact areas, and this is being applied for cheatgrass in the Western United States and woody encroachment in the Great Plains. But if we can anchor to these core areas or our intact grasslands and then work outward from there towards the problem, we're able to have we're able to start with our most cost-effective management and work towards a problem. They're implementing this strategy at McKelvey National Forest, and was talking to Julie Bain, the district ranger out there, and they got contracts for managing really low density cedar, and the estimates came back at like $1 to $2 per acre, which traditionally we wouldn't have even been worried about that early stage of the encroachment process. We'd have been managing where it's more dense. But she really pushed the contractors they didn't want to do it because it was different. But they're actually going to spend more of their time riding around on UTVs looking for trees to cut down, compared to sitting in a skid loader cutting trees. And so we're seeing this approach can be a lot more cost effective and cover a lot more ground. I want to jump into an example to help continue painting that picture of how this is implemented over time. So what we have here is Nebraska National Forest at Halsey. In black here is the largest hand-planted forest in the Western Hemisphere, where we've had encroachment over time. So in black, we have the woodland transition stage, and in red, we have encroachment. This is 2010, before management was really strategic in this landscape. What they started doing is adopting this defend the core, grow the core approach. And so by 2020, they've actually been able to establish an intact core and build on it over time. So what they're doing is they're going through with a mechanical treatment, they're cutting off all the trees within a unit. And then within the next 6 years, they burn it. Why do they burn it? Because they're taking care of the seedlings and the seeds that were left behind from that initial treatment. Once they burn it, these units are far enough from a seed source that they have very few incoming seeds. And they have a plan to be burning these units on a 10-year rotation to account for that 5% of seeds that are making it in. But what they have on the edges here, I'm showing, is that's that 200-yard zone where you're having 95% of your seed dispersal. And so the way they're managing that again is through fire. Their future vision is to turn the entire west side of this public land property to an intact grassland. We talked about eventually they'll get to this side, but their concern was that if they don't, the east side is more encroached. And if they focus on this side, the east side, they were concerned that they would lose the west. So one of the things they decided, through several work meetings, was to focus on the west side and get that cleaned up, and then they can move to the more infested area. The same strategy is being applied at McKelvey National Forest. They're in the earlier stages. That's new guidance. I want to just share an opportunity, because I know there's probably land managers here tonight. My position is funded to do science co-production for grassland conservation. One of the things we want to do is share this new guidance, and we will actually co-produce integrated management plans with land managers, which we're trying to grow and support collaborative partnerships. There's been an incredible amount of adaptation in Nebraska, and that's something we're willing to continue doing, is sharing new guidance and helping develop new management plans across the state for properties small and large. We're especially excited when people are working with their neighbors and willing to really grow these intact areas and reduce risk and vulnerability in grasslands. One of the things we can do through this co-production process then is we can actually track outcomes and show how what's been done on a site has reduced vulnerability, as well as things like increased rangeland productivity and some other data metrics. So with that, I'm happy to take some questions.
Well, Dillon, in the chat there, someone mentioned, can you remove the female trees from shelter belts and eliminate the problems of shelter belts being a seed source? And I made a note that I don't think the scientists are 100% sure that if you take out all the female trees, that there won't be either some female trees that haven't produced berries in the past or they're changing sexes. I think the science is still out on that. Do you know anything more on that as far as going into a shelter belt and removing the seed-bearing cedars? Does that work, or can that work?
It's something we should be experimenting with, because you're right. I mean, it is a possibility that we could have sex switching in trees. But we are with this new guidance out, where I've had more and more conversations over the last 2 years about how people are getting creative about managing windbreaks. And so that's really encouraging to hear. I mean, we should be experimenting with removing female trees from windbreaks and how that works. We should be experimenting with how we can establish windbreaks without seed-bearing trees. These are all have potential to be part of the solution. We've also heard a lot of people starting to remove windbreaks, really assessing which windbreaks are still serving that purpose on their farm or ranch that they were intended to serve when they were planted, and if they're no longer serving that purpose, removing the windbreak, given the risk that it poses to the grassland.
Okay. I know Homer Buell told me that he was taking out shelter belts that he planted as a kid and that his father and grandfather planted up on the edge of the sandhills. He said it just wasn't worth it because they were starting to see cedars taking over some of their pastures. So he said it just wasn't worth it. And other people are switching to man-made, shelter belts for cattle, windbreaks, putting things up made out of wood and metal and things like that. So there are other purposes. Does anybody else have a question? Throw it in the chat or raise your hand or go ahead and unmute yourself.
And I gave a talk in Imperial, and after the talk, someone came up to me and said, about what percentage of a windbreak is female? And I said, I don't know. And he said, well, I hope it's not too much, because I'm going to go cut all the females out. And if it's, he said, my wife will kick me out of the house if it's too many, if too many of them are females. So we went back and looked, and it's about 50% female, like we'd expect in windbreaks.
I see someone's asking about honey locusts, that they're a big problem at Spring Creek and a lot of other places. Can you use a similar approach to honey locusts and elm trees?
Yeah, similar approach is going to work. We see those more in the tall grass prairie area. Same approach will work. The dispersal mechanism of the seed is going to be different. So that 200-meter distance you're going to see changes. So one of the big things with honey locusts is if you have cattle dispersing the seeds, it's really important to understand how cattle are moved around. In certain places, they've used quarantine periods before putting them out into uninfested pastures, so that any seeds that have been ingested can have time to work through the cow. So that's one of the big differences that you'll see with species that could be distributed by like livestock.
Okay, I see Ann mentioned that 45 to 50% of the tree shelter belts were females that she dealt with, and they filled in pretty nicely after taking out. I know cedars will fill in once they've been given some room between them. The branches will fill in some of that dead area. So a shelter belt can withstand some thinning out for sure. Do we have any other questions? Anybody else want to throw something in the chat or just speak up?
I've got a question.
Okay, Tim?
maybe not, you can answer this. If you find a patch of cedars that have been in place for, let's say, 5 to 10 years, and you remove them, what kind of regrowth do you get underneath the, especially if they're densely packed? What kind of regrowth do you get in the grasses underneath the old cedar trees after they've been removed?
Yeah. We studied that exact process. So what we found is the re-encroachment process is not like the encroachment process. It happens much more quick. It's when we compared that re-encroachment to a grassland undergoing the initial encroachment process adjacent to it, we saw seedling establishment with re-encroachment happen immediately, within 1 year after the restoration treatment. In a grassland 50 meters away, we didn't see establishment of woody plants for 15 years. So we see much faster rates of re-encroachment. By the 8 to 10 year mark, that's when tree cover really starts to take off and increase exponentially, which kind of marks the process, the point where it's going to get much more difficult to restore that with fire. Like your restoration costs are going to increase quickly after that, 7 year mark.
Okay, Dillon, Chuck has a question in the chat. Can you see his question or do you want me to read it?
I can read it.
Okay.
I think, Chuck, are you referring to, I mean, I know what you're referring to. So if we're talking about species composition and is there that historical benchmark that we're looking to restore? I think that comes down to how in different individuals why they value grasslands. If having those native species and that, what we view as that historical tall grass prairie or prairie condition, then that can be really important. I think the biggest thing for this effort is maintaining a grassland, whether that's a novel kind of new grassland state that still has some invasive grasses or forbs. The focus can be on really keeping grasslands on the map, whether that's species composition. I think that's going to really boil down to how the grasslands being used and how the values that the managers have. Does that answer your question? So no clear answer on that one. It's about as clear as mud.
Now, Ann mentioned to mention brome grass. So I'm not sure what she's referring to there, but do you have any comments about brome grass? It's just about as bad as eastern red cedars in some places on our native.
Yeah, I mean, that can be does fire kill it? Fire can be used to, and Dave Woodin's a great with the University of Nebraska is a great one for this. Fire and grazing can be used to set brome grass back. So if we burn in the spring during the growing season, we can reduce its seed production. If we burn it and graze it, we can shift that composition to more of our cool warm season grasses. So fire use over time can be very effective for managing brome grass, but it's a process. It's not like a single treatment method at all.
Okay, let's take maybe one more question. Does somebody have a question? Want to unmute yourselves and speak up? Someone have a last question here for the evening? I might ask Arliss, do we know who our speaker is for July? Do you want to mention the speaker for July?
Okay. It's going to be Ted Eubanks. He actually lives in Texas, but he's done quite a bit of conservation work in Nebraska. And he hasn't narrowed down his topic yet, but what I have is conservation education work in the Great Plains, especially in Nebraska.
Okay, I know Ted Eubanks did a lot of work with Game and Parks when they were doing some in-stream flow studies and things like that. So he's pretty well known in the field.
And he's been on the National Audubon Board more than once and for long periods. So that's how I knew of him.
Okay.
Okay.
Well, Dillon, I want to thank you for joining us tonight and thank everyone for joining us. And, you know, if you want to come out on Saturday and pick some seeds and see some blooming prairie, come join us. Otherwise, keep an eye on our webpage and Facebook and the Babbling Brook. And thank you very much, Dillon.
Thank you. Enjoy it.
Thank you.
Thanks everyone for being here.
Thanks very much.
Thank you. Very good.
Tell me, what do you got?
Thank you. Great talk.
Thank you very much.